Welcome once again. This is the lecture number 11 of the AI class. We are going to see some special topics. And the first special topic that I wanted to talk to you is optimization. And it's not new for you. Optimization, you know. Okay. So here in this, I would first go with respect to what we have done earlier. So here in this slide, optimization means there are some scenarios where multiple solutions are possible. Okay, there are some scenarios where only single solution is possible. For example, if I give you what is 5 plus 3, so there is a single answer that you can give me. Okay, but if I say you something else, what is, for example, if I give you a graph, or I give you a map of the city, and I ask you that can you bring a can you bring can you come from here to here? For example, let me ask you that this thing, can you come from here to here? So there are multiple paths. So you can come in this way also, you can come in this way also, you can come in this way also, this way also. Okay, these are the three paths that you can have. All these things are solutions. So here in this example, there are only one solution. Am I right? Here there was only one solution, that was it. But in this case, when I'm asking that can you come from point A to B, there are path 1, path 2 and path 3. There are three solutions, P1, P2, P3. There are multiple solutions. So all of them are solutions. Then we actually go and focus on the point that whether any of them is better than the other. And going to that particular thing is called the optimization. We want to do the optimization. Is it clear? Am I making sense?
Yes, sir.
Okay. So we
The
want to,
best solution we are talking about, sir. Though, so
yeah,
within the available solutions, we
hmm,
will try to identify the best solution.
correct. Yeah. So there are various solutions. So there are first we have to understand these two cases where there is one solution only and multiple solutions. In the case when there is multiple solutions, we want to go to the better solutions. Okay, and this better solutions here in this example, if you say if you see this thing, so how can we say that which solution is better? Maybe we want to understand that what is the distance, okay, or what is the time that is taken from this to this, reaching from here to here. So let me tell you, it may be also be possible. For example, here it looks like that out of P1, P2, P3, which is best? Can you tell me? P2, because looks like that it is direct. So my graph is not that good. So who agrees with me?
It's P2, sir.
Looks like P2 now, because P2 is
Yeah.
direct. But
Yes.
but you don't know. Okay. Let's assume it's a hilly terrain. Okay. In the hilly terrain, you only see that the roads are something like that only. Okay. So why it is crossing and you are coming from this way? So let's assume that there is a river that is passing from here, and there is no road from here to here. So you have to go by foot from this place to this place. Okay, but here in this way you can use a car also, and you can go from here to here. So if I, instead of distance, if I say time, so maybe P3 would be better. However, it is very fast, very far. Am I right?
Yes, sir. And
So
traffic situation is also one
uh,
could be one
well,
condition.
yeah, definitely. So there will be multiple conditions. So we must focus one thing, that how to define goodness of this particular solution. The first thing we must know how to define goodness. If the goodness is distance, then P2 is good. If the goodness is time, then P3 is best. So first we have to try to understand that what is the goodness of that particular solution. So let's assume that I'm going to plot a graph where one side there is goodness. It says that objective first. There is another name called, technical name called objective function. So this is the goodness of my solution. And let's assume that all these things are solution. All these points on this particular state space are the solutions. Let's assume that they are the solution. So what happens that if I'm here, so goodness of my solution is this. Okay. So it is a very good solution. Am I right or not? But if I'm here, so it is not that good. So I have to do something, because I'm at this particular point. I have to do something so that I can creep it into this particular direction. So so I can get this particular point with respect to whom the solution is actually better. Yeah. Yes.
yes sir.
So सब लोग बोलो भाई, ऐसा नहीं होगा, मजा नहीं आ रहा है. So what happens ना कि we want to find out the best solution. So in these cases, when this kind of scenario is this, we want to find out the better solution. And now the technique comes. The how can you do that? The question comes that how can you do that? What do I mean by this? That let's assume because you don't know the solution. So how, one way that you randomly pick any point, you say that I'm here. So what is the goodness of the solution? This much. This much is the goodness of your solution. Everybody okay? This is the goodness of solution. But I want to increase the goodness. How can I increase the goodness? This is what the question is. Can anybody answer for me? How can I increase the goodness of my solution?
By analyzing some conditions, sir. So
Yes. Yeah. So some condition. What is that condition?
now I would give opportunity to others to speak.
Huh. Anybody can please pick. Yeah. What is that some condition? And nothing is right or wrong. Okay. We are here to talk. So we get an opportunity to talk to you. Please don't be shy. Okay. Nothing is right and wrong. Okay. Huh. Tell me. What is that some condition? I'm going to pick the name. Is it embarrassing? I would not do that. Please participate. Tell me that what could be that thing. Okay. Tell me. I'm not never expecting right answers. Okay. Because it spoils my class. Please give me wrong answer. So what would be the wrong way to do that? Yes. Tell me. Hmm?
Probably finding a place where goodness is better than this current position.
Yes. Finding a place. So the basic question is this: how to find that place? How to do that? Now we are addressing this part. How to do that? Hmm? You can tell it. There is no problem. Very easy. So let me browse. Let me make it big for you. Okay. So what I was asking. So let us just focus on this particular part. Okay. So can I draw here? So it is if you focus on this, so this is the graph. Am I right or not? You don't like it? I can draw it. So let me tell you. Let's assume that I take this particular part. Control C, Control V. So I am going to take this part here. Okay. And I want to make it. This is what the computer science is. Control Z, Control V. Wow. I like the computer science. That's why teaching in computer science is very good. What is happening? I don't know. I want to make it big. Huh. Tell me. What can I do? So if you don't want to tell, let me tell you once again that this is not good.
Is it identify the local goodness which is
Are
having
okay. Yeah, I'm coming to this point. So you are telling that I was this particular point. I want to be better. So there are only two ways to go. Either you go in this particular side or you go into this particular side. So there are A and B. There are two other points which are in my neighborhood. You find out that what is the goodness of A, what is the goodness of B. How can you find out? There is some method. What is that method? Let me tell you 3x square minus 9x log of x cube. Let's assume that this is a value. I'm just absurdly writing anything. So what is the goodness at this particular point? It is, let's assume that this point is 5. So put the value of 5 over here and get that what is goodness of this particular point. What are the nearby point? They are, let's assume that A is this, B is this. So A is 4.9, B is 5.1. Compute that what is goodness of using this particular equation on these things. Can you find out this? Because you know the value of x, you can put it here. and then you can find out what is goodness. So let's assume that the goodness on this particular point is 10, and the goodness on B is actually 11, and the goodness of A is actually 12. Then where would you go? Where would you
A.
move?
A.
Definitely, you know that because this is
Ten.
the what you have to do. So one way we have also, I think we this thing we have already done with more details using when we were studying about the what was that hill climbing, na? So when you are here, you are considering that all nearby places, the places where the value is actually high, this goodness is high, you move into that particular direction. So by this you move to this particular direction, and here you this is the better, here this is better, but when you reach to the top at this place, when you reach to the top at this place, then after that you cannot move because all the nearby places are actually lesser than you. Now you cannot move. So this is called the local minima. Am I right or not? This is the local maxima. Sorry, this is the local maxima where you actually come over here. So this is the one way, and this is a very interesting way, and this is the way that actually people follow to move to this particular way. And I'm sorry that this is not only the way. So we have seen that there are various other ways also. Okay, so this is the one procedural way in which you can move to that particular direction. But in this, let's just focus on this particular problem only. So in our problem setting right now, I was here. I find out a way to reach to this particular thing. Yeah? But is it a best solution?
No.
No, because best solution is here. So how can I reach this particular point? There is no other way. There is no way. You would be stuck in this particular place. Okay. However, this is only not the thing that where you are stuck. There are multiple places. For example, here, when there is a flat surface, you also get stuck in this particular place. This particular place is called the shoulder, where you reach something and after that you are actually stuck over here. Sometimes it may be also possible that instead of this is a flat surface, you can say that there is some ripples. You are again stuck in this particular place. A very bad experience because now you cannot do anything. On this flat local maxima, if you are stuck, what you can do? One way, if you are coming into from this particular direction, you keep moving in that particular direction only if the values are same. Let's assume A and B both have the same value. So you see from previously which direction you were moving. You keep moving in that particular direction. You may be going to the better place because from here you have already know that what was there. So you may be if the surface is like this, let's assume the surface is like this. So if you are coming from this particular direction and you find out that okay everywhere both the values both the places value is same, you keep increasing, keep going to this particular direction. After that you see that now again you get the something to go ahead. However, the problem arises when instead of a straight thing there are some ripples. So what happens? You get the local in nearby. You again you are stuck into these kind of scenarios. So this you know that, na? I think we have discussed in the more details when control A print screen come back here and control A delete control V. So I think we have discussed this into more detail when we were into studying about the neural networks that actual loss landscapes looks like this. So here is you can see that there are here the areas where there is a ripple. So you would be definitely stuck in somewhere. Okay. And in this thing you can also think, let's assume that you start from here and here the actually this graph and this graph has a small problem also that the problem in terms of the thing that this graph was drawn to actually minimize the value and this graph is drawn to maximize the value. So let us also see here also, let's assume that here also you want to maximize. So if you are here, where you want to reach? You want to reach this particular point. So ultimately where is the maximum? Maximum is at this particular point. So if you are here, you may be reaching from somewhere here only. If you are here, you would be reaching to here only. If you are here, you would be reaching to this place only. Okay, so this becomes very difficult to find out that how to go ahead with these kind of things. So different kind of strategies are there. So we have one strategy we are today also we are going to see how to do that. Now I think you have the fair understanding of the optimization and the issues with the optimization. Am I right? You know that what is the optimization? That finding out the better solution. Okay, when multiple solutions are there, finding out the better solution is called the optimization. What are the issue could be the shoulder could be issue, flat local maxima could be in the issue, ripples could be issue. So there could be local maxima could be issue. So these could be various kind of issues. Yes or no? Can I stop? Can I say that we understood this point?
Yes, sir.
Yes. Okay. And this graph we have earlier also talked about that actually the surface is something like this. A very good paper that came few years back, which actually tries to plot this. This graph actually, this paper actually does not focuses on this thing. Actually, try to see that if you apply dropout. Do you know what is dropout? If you apply dropout in the network, then this surface becomes smooth. So this paper was actually written to prove this particular concept. All right, so this is what the optimization is. We understood that what is the optimization. So if we so so if we want to find out any kind of right parameter, so method is going to be that if you know that you have a parameter, you you know what is the goodness, and let me say that this goodness function is j. So you differentiate this goodness function with respect to this particular quantity. Goodness means you find out that what is the steepness of at this particular point. Okay, with respect to the steepness, you can go into the negative direction of the steepness. It actually, this particular quantity tells what? Derivative. This is called the derivative, and derivative tells that if you increase the value of w, how much you are going to get a gain into this particular j. So if you want to reduce the value of j, so you go into the negative direction of this particular quantity. So means you are going to modify the value of w by saying that w is equal to w minus this quantity. But sometimes this quantity could be very weird. So we can also apply use some kind of a constant to control the behavior. So this is a very common equation that you may have seen many other time in your machine learning thing, that how to update the weights. Okay, uh, we must understand one thing, that if in this kind of scenario, if I want to reach to this particular point, let's assume that I want to reach this particular point, and I am going to see that my neighborhood, that what is the in which direction there is a slope, and I'm going to the into the direction of slope only. So so this slope should have a kind of is nice kind of property, because even into the what I call it, it is even into the small neighborhood, it should have a small property, and that property is called the convexity. Who should have this property? Objective function, loss function, or J. Same thing. Okay. They have the property called convexity. If they have the property, if the function has the property, if this particular function has a property called convexity, then we are into good shape. What do I mean by this? I mean by this that we are in good shape means what? It is not coming here. Okay, then we are in good shape means what? That we can apply this particular formulation to find out the right parameter. What it is. So let me tell you that there is something, what is complexity, convexity. So idea is this, that let's assume that this is what the function is. Okay, and forget about the maximization here, because in general terms everywhere people talk about the minimization. Let me find out that I want to find out the minimum value. So here I say that the parameter is w, and here the value of j. Okay, the same problem again I'm going to formulate. Yeah, it is same problem. Yes or no? Yes, I'm formulating same problem, na? That I want to find out the maximum or minimum, right now minimum value. Yes or no?
Yes, sir.
Okay, so how can, again the same thing, how can I find out? You pick random value, you are here, and then here you find out that what is the slope. This is the slope, and as I told you that you are going to use this particular formula. This formula says that jw upon this delta dj upon delta w. What do I mean? That if you change something into, if you change this much into the w, if you change this much into the w, this is, let me call it delta w. So next point would be here. So this is how much you are going to get reduction into j. This is del j. So del j upon del W. If you find out this particular quantity, so so it is going to be something. So you know that this represent with respect to the theta angle, where it would be a negative quantity. It would be a negative quantity because when you increase the W, the J reduces. It is going to be a negative quantity. So negative quantity, this becomes a negative quantity, and you multiply with the alpha, it becomes a small value only, and here is it a negative. Negative quantity, negative means becomes positive. Then it means that your weight, if you use this particular formula, your weight is going to increase. Weight is going to increase means you are here, now your weight becomes this. Next weight is going to be something here. It is the right way to go now, because you know that where is the minimum, here is the minimum, here is the point where there is a minimum. So you would be reaching here, and if you apply the same thing over here, you would be reaching here. In the same way, if you start from here, for example, if you are here, then del W, if you increase the value of W, del J increases over here. So del J is positive, del W is also positive, del J upon del W is actually positive quantity. Yeah, is it positive quantity? If you use this particular formula, it says that W minus positive quantity means that now your weight are going to reduce. So next weight would be here. If you are using this thing to update your weight, then your weight would be this, and then again the weight would be this, again weight would be this, and ultimately we are going to reach to this particular place. So what I wanted to tell this, that this is a right strategy actually. This is the right strategy. This particular formula is a right strategy to, because if you are in this particular scenario, you have seen that if you, this is the optimal. If you are here, you are coming here. If you are here, you are also coming here. So it means that this formula is a good formula. But this formula works only if there is a property into this particular function, in this particular function, and this function, this property is called convexity. And what is convexity? Convexity is this, that there is a function, and if you put any 2 point, let's assume that this is point A, this is point B, any 2 points if you take. So what is the value over here? F of A. What is the value here? Can you tell me? F of B. So f of B. Okay, yes or no? Let me just quickly remove this particular part. Everybody, please let me know that do you understand this particular part. Let's assume that I have a function. I have a function and I'm going to find out the value at the point A and at the point B. At the point A, the value is FA. At the point B, the value is FB. Okay. Can you give me any point in between? Can you give me any point in between? So I can say that this point is A plus what is this point? A plus 1 minus lambda time A plus 1 minus lambda time B, where lambda belongs to 0 and 1. So when lambda is 0, so when lambda is equal to 0, this value becomes what? Lambda is equal to 0. This value becomes B. Am I right? When lambda is equal to 1, this value becomes A. Am I right? When lambda is equal to 0.5, then what is this value? A by 5 plus B by 5. 0.5, b a by 2, b by 2, a plus b by 2. This is the midpoint. Can you see this? Yes or no? Please let me know if I'm not
Yes,
making any
sir.
sense. So what I'm telling, that let's assume that I devise this particular formula where lambda can take the value into 0 and 1. Then based on the value of the lambda, I can find out A, point B, any other point I can find out over here. So if I ask that give me any point here, give me any point here, so you can say that this point is lambda A plus 1 minus lambda B, where lambda is some value between 0 and 1. You can say like that. Yes or no?
Yes.
Okay. So if you can say like this, then I can say that I can ask again another question, that can you give me that what is goodness on this particular point? So goodness is f point 1 plus 1 minus lambda into b. The goodness is going to be this, because on any point if you want to find out the goodness, let me say that this is f. So I can find like this. Okay. What was the goodness at the point A? Fa. What was the goodness at the point B? Fb. So if I also multiply the same multiplying factor over here, 1 minus lambda, okay, plus lambda time. If I make this particular formula, so this value is going to be greater than or equal to this particular quantity. If this happens, I'm not telling that it is greater than this. I'm telling that if this happens, because you know that goodness of this point, you also know. If it is greater than, if this value is less than this particular quantity, then if this condition satisfies, then I say that it is a convex function. Then I say that this is a convex function. Then I say that this is a convex function. Which is a convex function? Lambda. F, sorry, f is a convex function. What does it mean? That essentially A and B, if you divide them, and this particular quantity is actually this particular point. Okay. And the function point is actually this, goodness of function is this. So you can see that function goodness is actually lesser than their individual averages. If this kind of property actually is there, then we say that the function is convex. Once again, let me repeat, let me make everything clear. There is a function. I want to find out whether this function is convex or not. Why? Because if this function is convex, then I can apply this learning strategy to find out the right parameter. Okay, then I can apply this kind of learning strategy to find out the right parameter. How can I say that the function is convex or not? There is a specific property that for any AB, for any AB and lambda, if you satisfy, if this is satisfied, this formula is satisfied, then we say the function is convex. Okay, so once again, let me go to my presentation, and here I am. I'm telling that we need convexity if you want to do the optimization. Once again, let me quickly summarize everything. First thing, I want to find out the optimal solution. There are multiple solutions. I want to find out the better one of them. So the way is that if this function is convex, then we can use this kind of method to go into x and y direction. And if you change, because since by this you are changing the parameter, you would be reached to the optimal value. Nearly means the nearby local minima or maxima, you would be able to reach that nearby local optima. If you want to reach to the local optima, the method is that you update your parameter, update your value using this particular formula. Provided this function satisfied a kind of this function satisfied a kind of equation that is called the convexity, condition called convexity, and this we have discussed in detail. Any questions? Yes or no? Any questions? No question? Hmm? Are you there?
Sir, this
Let,
equation,
Yes,
let
sir.
us
Huh?
go ahead, Sanjeev.
Go ahead.
this equation part, can you please once again repeat this equation part, how it's
Uh,
satisfied?
okay. Sure. Please ask the question. Okay. What I told you, can you please help me to write what I just told you? Please help me to write what I told you, that if J is convex, we can use W is equal to W minus alpha time del J upon del W to get local optima. ये सब की समझ में आया? Everybody understood this?
Yes, sir.
Hmm?
Sir,
Now,
if J is convex or F is convex, function is convex.
yeah, actually, this is actually why I'm writing this. That the as F is also here, na. So I don't want to confuse you. That's why I write J. Okay,
Okay.
J is just a name of function. Okay, J is F in our case. Okay, J is F. And just to remove some kind of confusion, I use this. So there is a function. If J, that is a function, is convex, we can use this way to get the local optima. And what optima of what? JW. Ultimately, you want to find out what is the value of J for given W. Here W is this value. You want to find out what is that value of W for which this particular value is actually minimum. Yes. This, if you understand this part, at least one part is done. Okay, first understand this particular equation that I'm writing. That's why I'm writing this. Okay, here what I wanted to tell, that if everybody please help me to understand that there is a function J. Okay, I want that on what value of W, on what value of W, JW is actually minimum or maximum or optimum. Is it clear?
That is clear, sir. Yeah.
That is clear. So how can I find out the value of W, that value? So I say that randomly take any value and then you apply this formula to update. If you apply this
That is
formula,
this is little bit confusing, sir. Randomly take any value.
uh-huh,
So
okay,
there is no base for that. We can take any value.
yes. Let's assume that I randomly take this value.
Okay. Yeah.
Here goodness is how much? This much. But where is the minimum? Minimum is at this particular point with this corresponding to this particular value. I want to reach to this particular point. Hmm? So I find out, please focus on this and ask the relevant question. I want to find out what is this quantity. This quantity says that if I change the W value of W, let me say that if I change the value of W, because here the value of W, if del W is this, then how much change is in, because this is the another point. So here this would be value. So here the goodness is this, here the goodness is this. So this is the difference. This is called the JW, del W. Okay, del W is negative because final minus this value. If you say that this value minus this value, if you do, okay, if you say that f of here, let me say that W plus del W minus J of what is this value? Initial value. So this value is going to be del J, and this value is going to be negative. Yes or no?
yes, sir.
If you are not able to understand, please ask sir कैसे होगा पूछो. If you're not able
So,
to
please
understand,
repeat it.
negative होगा. Will it be
Yes, sir.
negative? क्यों? Because if the function is like this, then if you go forward, this is going to be smaller value. So final value minus previous value is final next step value divided by current value is going to be negative. This is negative. Yes. Hmm? This part is clear. If you don't understand, please ask the question. I'm not here to go away. Okay. I just wanted to teach you. If you understand, I'm done. If you don't understand, I'm useless. This value is negative or not?
Yes, sir.
Uh, yes, sir, this is negative, but if you start moving from O, the mid position, right?
No, no,
Then this would be
just hold on. We'll forget about
okay.
this. We'll
Okay,
talk
okay.
about this. This value is negative. So if
Yes,
I say, and this value is del J, del W is positive because you are going into this particular direction. So del J upon del W is what? Is negative. If I multiply with the alpha and put negative over there, this complete quantity becomes what? Positive.
yes.
If I add to this particular thing to the W, then the W increases or decreases.
Yeah, it would
Increases.
So initially your W was this, but now your new W would be this.
Yes.
You again apply the same procedure over here. Your next W would be this.
Correct.
You again apply the same thing. You would be reaching till this particular point. But after that it becomes negative. Ulta ho jayega. It would be in it. This quantity would not be negative. This would become positive. Okay. So this strategy is actually moving towards where there is an optimal solution. And let me give you another example. If you are, let's assume that randomly you pick this particular point, your error was this, then what happens? This quantity is actually positive. Positive means you are actually going to subtract the thing, because why it is positive, you can, for obvious reason, value is increasing over this particular point. So if you do the update using this particular formula, your weight is going to reduce, because this particular formula says that there is a negative and this inside thing says positive. So by this you are reaching to this particular place. Yes or no?
Yes.
Okay.
Yes,
So
sir.
if you understand this point, I'm very happy to say this particular moment that what we have seen, that if this kind of function is this, whatever place you randomly pick and you use my method to update, it is going to take you where? It is going to take you here. Means what? That this is how you get the solution. This is how you get the actual solutions. Yes or no? This is how you can get the optimal solution. Now only one thing is remaining that I wanted to add. So you understand that particular point. This is my statement. Okay, you understood that statement, that using this particular formula you would reach to local minimum. Clear? Now one more thing is required, that here I was drawing the function like this. If the function is not like this, then how can I prove? My complete proof was my complete convincing on this particular factor that the function is like this. Yes or no?
Yes, sir.
So what is this? इसको क्या कहेंगे? What we call it? This if
Convex
this kind,
curve.
this function is called convex curve. What property it has? That pick any 2 points. Pick A, pick any 2 point B, and use any lambda that is inside between 0 and 1. So you can say that you can find out another point by saying that lambda time A plus 1 minus lambda time B. So if you find out that what is the value of function or j, whatever you call it, so this value would be here. Okay, and if you find out that what is the value of on A, it is this, on the what is the value on B, it is f of B. If you divide them and you again apply that lambda time fa plus 1 minus lambda time fb, if you write like this particular value would be this, because actually you are dividing, you are equally dividing the things now on the line. Is the equation of line. So this point you are going to get. But if you actually use A and B to find out another point, and on that point if you evaluate the value of j, then this value is this. Yeah, what does it mean? That there is a gap. If there is this kind of gap, yani it means that this function is actually satisfied, then we say that this function is convex. And for the convex functions, for only convex functions we can do this particular method to find out the solution. Yes or no?
So, sir, this gap can be positive or negative, anything.
No. It is this gap. Actually, I am telling now, this value is actually smaller. So from function side, if you go, it is lesser than what you get from this particular line. So this point is actually below this particular line.
Yeah, got it now, sir.
So this condition is called the convexity. If there is convexity, then this particular function would work and give me the optimal solution. Yes or no? Understood?
Yeah, yes, sir. Got it.
Please ask the question. Okay, I'm here just to tell you to my best of my abilities. Okay, it's very easy. Okay, fairly easy, but there are some mathematics. Now, let me solve one of your mysteries. Hmm. If I ask you that if I give you a function and ask you whether this function is convex or not, can you do that? Give a function and ask you whether this function is convex or not. You find out with the value of some value for which this cutting condition is violated. You say that this is not convex. Or you try to draw that particular function. This is not convex function. Only in this particular range it is convex. Okay. So convexity, one question. Another question, if I say that, right, for example, a few minutes back I have written 3w square w square minus log of w cube plus something, some equation I'm going to write. And I'm going to tell 3-4 values, and I'm going to ask that what is the goodness of these things? What is the goodness of these things? Again, you can find out the goodness by putting this into this particular formula. This is again a mathematical thing that I can ask. That can be asked into the question paper. Okay. Out of multiple solutions, I say I can ask that which is best. So for each of them, you find out that what is their goodness and find out that which is the best one. Yes or no? Yes. Okay. All right. Very good. Excellent. Next point that I wanted to talk about, the ant colony optimization. No further questions?
Sir, one question I have just related to range of the lambda. So is it something always to be in this range 0 to 1? I mean, if it is
Because
apart from that, we don't.
no. I just
Yeah.
wanted to see convexity between these 2 points A and B. So if you put any value of lambda in this particular way, actually what you are going to get, that any point in between you are going to get. If lambda is 0, you are going to get A, B. If lambda is 1, you are going to get A. And for all other values, you are going to get some point in between. So in between, this is a standard way. Actually, I'm telling lambda, but here I have written alpha. Happens like that. At the time of typing, I have done this mistake. I'm sorry for that. So that is fine. You understand lambda, alpha, what is the difference? Okay. Yeah, so this is what it is. No more questions? Hmm? No more questions?
Nope.
Good. Now we are going to see very interesting thing. Ant colony optimization. Does anybody knows about this? What it is? A very common name. Okay. I don't think that you may not be knowing. So on every slide there is a reference. Please, this is the reference of the paper. Very influential paper. 15,000 citation of this paper. Came in 2006. Very influential paper. What is ant colony optimization? So my first question, anybody heard about this? Do you have any idea?
No.
Okay. Are you ready to learn something very exciting? Hmm?
Yes, of course.
Yes, sir.
Not sure.
Of course.
So I'm telling that let's assume that here is an ant. Hmm? And here is in food. Hmm? And let's assume that there is one path that goes like this. There is one path that goes like this. Okay, that reaches over here. ठीक? So what happens ना? ये अब मुझे कहना नहीं चाहिए, उसमें कोई बुराई नहीं है, बट आई एम टेलिंग यू. आपने देखा है कि डॉग जो है जहाँ से जाते हैं वो कभी-कभी कहीं पर सुसु करते हैं.
Yes.
Yes.
So this is their technique. Okay, to remember the things. So something called pheromones they want to release in the path. तो let's assume that 2 ants यहाँ पे आई. अब उनको इधर जाना है कि इधर जाना है कि इधर जाना है. They don't know. So एक इधर चली जाएगी, एक इधर चली जाएगी. है ना? लेकिन वो जाएगी तो रास्ते में यहाँ पे बहुत सारा फेरोमोन छोड़ती हुई जाएगी. है ना? मान लो वो 1 मिनट में यहाँ पे पहुँच गई. कितना मिनट? 1 मिनट में. फूड उसने लिया, खाया, वापस चली आई. फेरोमोन आने जाने में मान लो उतना ही लगता है, तो ठीक है, इतना फेरोमोन आ गया. Second ant is going into this particular direction. Okay, she is also emitting pheromones. Okay, when she reaches over here, he eats the thing and come back. Let's assume that come back in the same path. Okay, and let's assume it takes 2 minutes to reach into this particular place. Okay.
Okay.
2 minutes. Let's assume the complete going and downing is 1 minute. Okay, here and 2 minutes here. So GT यहाँ वापस आ गई. So जब at the time 2 minutes he would come here because there is not only single ant, thousands of ants are there. So second ant would also coming just behind him. She would come here and eat go here. So how many ants has actually gone into this particular path? 2 ant. How many ant into this particular path? 1 ant. Am I right or not? नहीं समझ आया बोलो. You're not able to understand. Let me know.
Out of 3 only 2 and 1.
So one ant behind another is there. So one ant went here and came back. So in 1 minute. At that when she came back at that time, this first one was only here. Okay. So second went here and came back. At that time he went here and come back. Something like that. Okay. When he reaches here, at that time he was here. When he came back, then it reaches here. Then again second one came back here, so he came back here. Second one came back from here to here. At that time he was here. So when this particular fellow come back here, at that time here there was one, and here in this particular side 2 ants are actually gone. So next ant when he comes here, he have to pick that whether he should go into the path A or path B. He sees that okay, the pheromone in this particular side is 2 times as compared to here 1. So the probability of going into this particular side is 2 by 3. Probably going to this particular side is 1 by 3. He chooses the things using this particular probability. Because he sees that lot of pheromones are there. I mean, many people are going in this direction. Why should I go into this particular direction? So 2/3 of the ants are going into this particular direction. Okay, so many ants are going to this particular direction. Many ants are going to this particular direction. Very less are going to this particular direction. And over the period of time, what happens that pheromone is full of pheromone this particular place, and now nobody is going to because here, and after some time pheromone disappears. So by this they discovered that this is the shortest path from here to here. So what kind of things we were doing earlier? Was it good? Finding out derivative. Who is going to find out derivative? they don't want. Without using derivative, they can find out that what is the best way, because both were the solutions. One solution was better because here the path was actually smaller, but you can see that very interesting idea. You got the idea?
Yes, sir.
This can be done. Ant colony optimization. It takes inspiration from the social behavior of the insects and of other animals for the problem solving. So they are solving their problem. Okay. So now we want to talk about the particle swarm optimization. Very interesting algorithm. Okay. So what it says this. Okay. In a similar way. So we are actually whenever we have a problem now, we try to see towards the God, that can you solve me something. So God has given few algorithm, and which actually other creatures have, we don't have. So we wanted to use that thing for our advantage. So there is a very interesting idea that you know that how the birds fly. So you know that they create a kind of constellation. So there is a bird, then next bird, then next bird. So okay. So next bird. So they are flying, and there should be some target, and based on the target they are actually moving into some particular direction. They are doing something. So actually, particle swarm optimization actually says that there is some leader. Are you okay with me? Who is leader? If I say that A, B,
Front.
C, D, E, F, who is leader?
C.
C is leader. So if there is a there are, even if you see anywhere, if there are a lot of hens, they are moving, there would be some leader. There will be some leader. And again, if what differentiate leader with others? Leadership qualities. Huh? No. There is something called fitness. Okay, again the same word, fitness. His fitness is more than the others. Now again, what do I mean by fitness? It's not a physical fitness again. Fitness towards goal, that how near to the goal he is. If you want to find out that how near the other people are with respect to the goal, you can see that he is the most nearest person with respect to the goal. Am I right or not? Find out the distance. Who is the most nearest? Okay,
Yes.
so he is the fittest person. Okay, so all other peoples first do what? First do what? That find fitness of own. What is your fitness? Hmm? Everybody, if there are multiple things over there, we call it particles, and swarm means multiple things are there. Okay, many of them are there. So if there are many birds are there, they try to see the fitness of own, or how fit they are. Means how, and now by fitness means what? Right now, what it is? Distance. Okay, distance from the target. So this is they are going to find out, and then definitely you want to find out, choose leader. How to do that? Can you tell me? Can you tell me? Hmm? Tell me how to choose a leader.
Particle with highest fitness.
इतना time क्यों लगा? Why you spend this much time? I was just about to nervous. Okay, so choose the leader, because now you know everybody is that how fit they are. So then you can find out who is the leader. You find out the leader, and then orient yourself. Orient to leader. Of course, there is some randomization also, because they sometimes they don't like his face. They do some kind of randomization. So everybody orient into that particular direction. Means what does it mean? That move into some particular direction. Okay, you see that in which direction this particular leader is moving. In the same direction, you also move with some kind of randomization, and I would not go into the mathematical detail here. So if everybody, let's assume that he was moving in this direction, now he is leader is going in direction, so he would orient himself and move something into this. Maybe not fully, some here, maybe uh, he moves into the fit, maybe some difference. So by this, actually, what happens, na? He, if he goes wrong, other person can be into the line of sight, because let's assume that this was the objective, they were flying something like this, but if they fly like this, then somebody else from here get nearer, and then he takes the lead, he start coming into this particular direction, and then everybody changes their direction, and therefore they go into something like that, they do maneuvering, something like that. Move with some sort of randomization. Okay, so that you also get some freshness. All right, so again, after that, what to do? In every step you are going to change ki exit or not? Exit, you exit in two conditions, whether if your epochs are done, means timeout. If you can say this, that it is, if it is timeout, timeout, or accuracy that you wanted has been achieved. Two things could be possible, yes or no? So then you exit, and if you don't exit, then you go again, find out the fitness of phone, again do the same thing, and by this you would be moving from here to here and somewhere, and you would be reaching to somewhere, someplace. So am I able to give you the idea?
Yes.
If you are interested, you can read this paper. 1995 paper, Particles from Automation, very influential paper. Few minutes back, I told you that it's a very influential paper. How much citation it has?
10,000.
15,000. And how much citation this paper has?
70. Oh,
74,000.
74,000.
Excellent paper. Okay, so it gives you the basic things. Then after that, many things started. So try to understand and how to do the modeling of these kind of thing. I call upon you that please read this paper. It's very easy paper. You just see that. Very easy paper. Okay. Any questions?
Let's
So all right, let's go to the next slide. Fairness in model. So what is fairness in machine learning? What is fairness in machine learning?
It is not biased or something.
Acha, let me tell you one thing. Okay. Okay, what is biasness? Okay. And this I always tell you. Okay. What I wanted to tell you that if I go mathematical, would it be fine? Look, I have a value of a parameter x1. I have a value of parameter x2. And there is a function that takes x1 and x2 and give me the value. Okay. So it has 0, 2, 3, 1, 2, 1, 1, 2, 3, 4. Some values are there. And there is a function. It has a value 2, 1, 1, 2, 0, something like that. So this is what the database I have. I told you the task of machine learning is give you a function that also takes x1 and x2 in such a way so that the what h1 is going to produce and what h is going to produce and what f is going to produce should be same. Our objective is that f is actually h. This is our objective. Yes or no? Yes or no? There are various choices for h because I don't know. I can put e to the power x1 plus e to the power x2. I can write 3 log x1 to the power e to the power x2 multiplied by this way. I can write that 3 x1 plus 5 x2. In how many ways I can write the function? In how many ways? So you know that this is one way where I can say that weight is 1, weight is 2, weight is 3, multiple weights I'm going to put, and you change the weight, this function changes. Here also is a different kind of function. Here also it is a linear different kind of function. So how many different kind of function, infinite kind of functions? For each of these choices, how many values are possible for the parameter? They are also infinite. So it's a very huge space. It is a very huge space. From where actually I am going to search? Yes or no? But as a machine learning instructor or person, I know that this is a better function as compared to this function. I am telling that I am not going to use this. I am going to use only this particular function. This is I am imposing on you. This is I am imposing. Why I am imposing this? That use only this kind of function. Don't use this kind of function. Why I am imposing this? Because I have a bias for this kind of function. That looks like that this works into the area. Do you understand what is the bias is? This is my bias that I would be using this particular function only. Now my question is it a good thing or bad thing? Is it a good thing or bad thing?
Not fair thing.
It is not fair. Just think that I am not blindly telling you that you use this thing. I have understanding that this kind of function works. I'm not blindly telling you this.
Yeah, then it's fair. So we
It's
have
a good
proof
thing.
and evidence. Yeah, it's good.
Yeah, it's a good thing. For example, if there is a advocate, he goes to the in front of the judge and want to argue for a particular case. There is another advocate, one advocate, another advocate. So they present the case in a different way. Why he present in this way? Why he present in a different way? Because of the learning that he have done. This is his bias. Why he is presenting in this way only, not in this way the present second person is having? It is his bias. So this bias is not bad. It is very, very important thing. In the machine learning, bias is very important thing. It should be there. But however, if I add this bias to the data, it becomes bad thing. Now data is biased. When data is biased, it becomes a wrong thing. Everything was good, but when the data is biased, it becomes a bad thing. Why? So let's assume, just for the sake of argument, that that in a database, biased database, let's assume that without bias, I have a database. So I have, let's assume that this is the database. So there are, if it is not biased, so these are the positive classes. I say that these are the negative classes, and these are the positive classes. Oh my god, can I put it? Okay, this is the positive class, this is a negative class. If I start, if I develop a model, M and apply on this data, so let's assume that these are the items my model is not able to characterize well. Okay, so there are two type of things are possible. That you know that confusion matrix, nice standard thing that is called the confusion matrix. When true thing is called true, when true thing is called false. Let me know what I'm writing. In the standard system, what happens that true thing means the right thing is I call right to the right thing. I say a true thing is called true. True thing I calls false. So it is false, negative, falsely negative, no? Because it was two thing, but you are telling false. False thing you are going to tell true. Okay. So it is false, positive. Okay. False thing you are going to say false. It is good thing. Correct thing you are telling correct. Wrong thing you are telling wrong. So this is a standard way to evaluate any kind of algorithm. If I want to find out how good my system is, I can say that what is accuracy, and accuracy is true said true plus false said false divided by true to plus ff plus tf plus ft. This is how you find out this. Yes or no? Yes or no?
Yes, sir.
Okay. So if my database is such that instead of this kind of database, I get this database where there is no negative examples. All the examples are only positive examples only. All the examples are only positive example. So this goes away. Yeah, let's assume that very less point is there. Okay, only 5-6 points are there. 1 lakh points are over here. So this becomes very less. So all these both the quantities becomes very small. If my model is very good, this is also very small. If the model is very good on this particular part, if my model is very good on this particular part, so even for all the items my model say is wrongly classifying, if for the false item all the items my system is wrongly classifying, if my model is good over here, then my accuracy is 99%. Very high, 99.99% accuracy. Not able to understand? Let me give an example. Let's assume that there is an aeroplane, okay, and some peoples are going to board to this particular airplane, okay, and you are going to develop a system that whenever a person is going to come in front of this system, he is going to evaluate him, okay, and tell that whether he should go into this board in this here or not. And this is going to tell that whether this person is terrorist or not. Okay. So once again, what is my question? I have developed a model which 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 evaluates the person and tells that he is a terrorist or not. Hmm? And it goes into the system. So how can you build this kind of system? Just give an idea. Just give me an idea. How can you build this system? How can you build this system? You have to identify this person and you have to do so many things. You have to read so many data about them. Then only you can tell whether he is terrorist or not. Yes or no? Yes or no?
Yes,
Yes,
sir.
sir.
It is a very heavyweight system that you have to make. But let me say, let me give you a very simple example. So say everybody that no, he is not a terrorist. So what would happen? How would you determine your accuracy? Out of let's assume that let me give you the data. In last year, let's assume that 1 lakh peoples actually travel the flight, and 5 were out of them were actual terrorists. So your system is going to allow everybody. Okay. So is there any person who is you are going to stop? No. So true, how many people you are going to apply at how many places you are correct? 10,000. At how many places total how many values are there plus 5? So what is the accuracy of the system? Because these 5 places were there where you are actually doing error, because you are also allowing them. Na? This is the place where your error would be. But what is the accuracy of your system? Can you see that? So this is the problem. When the data is biased and you determine accuracy based on this, then there is an issue. Okay. Okay. So how to tackle with this? So with the data biases, model inaccuracies such as these may be possible that you treat unfavorable to the different things such as different race, gender, disability, and different kind of orientations. So what is the way to solve this issue? If this is a problem, that how can you solve the fairness issue? One way is to fairness through unawareness. One way to solve this thing is fairness through unawareness. Means what? I am not aware that what kind of data it is. So I'm not considering that who is right, who is wrong. So am I right? Because in my I have not developed the system which actually does this kind of analysis. Am I right? My system does not have, for example, if I don't want to be bad to any kind of gender or any kind of race, so my system is not developed in such a way so that it consider race as a thing. So whether my system would be fair, will it be fair? I don't consider this parameter. Will it be good? Answer is no, because they may be differently represented as in this particular case. Yet this particular category was very much less represented. So you are thinking your accuracy is good, but it was not like that. You are not fair with those systems, even if your accuracy was this. Next method could be equalize odd. Means if you want to find out that, let's assume that there is an attribute such as gender, such as male and female. So if 0 and 1 represent 0 represent one gender, 1 represent another gender. So if you are going to find out the value of y, so this value prediction should be, the probability of value prediction should be same with respect to every that particular class. Okay, so this is one way. Can you see this? That if the value is 1 and if value is 0, the probability that you are going to give the value of y should be same. Means whatever accuracy is there. So this actually probability actually here actually represent that what is the correctness, what is the correctness that you have. So you must be with the same kind of accuracy you should predict in all the different races. Does it make sense? Are you able to understand this? Hmm? Hmm?
Sir, what is A here?
Yeah, A is the attribute for which we want to bring the fairness. For example, with respect to gender, if you want to bring the fairness, so A is equal to, when A is equal to male and A is equal to female. In both the cases, if you are going to predict that somebody is doing something, whatever for whatever thing, because why you are wanted to do that. Let's assume that there is a system that wanted to predict that whether this person be hired or not. Okay, this person should be hired into the company or not. So y actually represent, I want to tell that this person should be hired or not. So the probability that when he is actually male or female, in both the cases should be same of hiring him. This means this. Yes or no?
Yeah, got it.
Anna? Actually, I have told you wrong thing. So model operates actually in two ways. So probability of only accepting is not like that. There is rejection also. Now, two things can happen. He can be accepted as well as rejected also. So probability of rejection should also be the same. Because here I am telling the value of y. So value of y could be accept and reject. So in both the cases, if I say that what is the probability that this person is going to be accepted if it is male? What is probability that this person is going to be accepted if he is female? This probability should be same. Yes or no? As well as what is the probability that this person is going to reject, and what is the probability this person is going to reject if it is male, and if it is reject if it is female, they should also be the same, both sides. Yes or no? Yes.
Yes.
So this is a good idea. This is a good idea. Actually, this is the right idea. Okay. So the probability of selection and probability of rejection both should be same with respect to that particular category. Another thing is equalize opportunities, actually this is what actually I was telling earlier. I told you that the probability of acceptance, because actually what happens now in the rejection cases, we are sometimes not that much interested. So we say that okay, I forget about the rejections. When I accept the thing, then at that thing the probability of acceptance of boy or probability of acceptance of girl should be same, or whatever race or whatever disability or whatever thing is there, they should be same. If I only consider the acceptance, then it says that it is called the equalize opportunities. If I consider both the things, acceptance and rejection, then it is equalize odds. There are various things that comes into the things into our way, and that actually makes the thing difficult, and such as something called correlation fallacy. Okay, so actually this is not okay. So this is again a very difficult kind of thing. So let me draw a graph. Okay, and let me draw another graph. Okay, so if I don't know the property of A, this graph, if I don't know the property of this graph, and I know the properties of this graph, I know the properties of this graph, and I want to find out the value of I want to find out the value of red curve. Okay, so can I use the value of blue curve at that time? Okay, so let me make it easy. So let me give another graph. So can I use blue or green? Which one I should use?
Blue one.
Blue one, है ना? Everybody agree that we should use the blue one. If I want to find out the value of red, I should use the value of blue one. Everybody agrees? Hmm? Nobody is telling. So I should use the blue one, but I have not told you that what is the property of blue ones are. They may be totally disrelated things, but their curve is coming something like that. It may be possible, na? That they may be totally disrelated thing. For example, this is how much water is there into Ganga river, and this could be that this could be how what is the production into a Hyundai company, number of cars produced into the Hyundai company. What is the relationship? And this third curve could be say what is the stock market, what is the stock behavior of the cryptocurrency. But because of this falsely, sometimes it looks like that similar. I take this kind of things. So this is a big problem into the fairness. Sometimes we this overgeneralization, we actually generalize the things so much, and after that we get like looks like that everything looks simple. Class imbalance problem we have seen. All these things are a big problem into this thing. Hope you understood the fairness part. Is it clear? Now we come to the last part, and I would, and this is not very difficult. Everybody knows that now. And let me tell you, let's start by an example. Let's assume that there is some patient. Okay, let me give you an example before starting this session. So I say that let's assume that there is some patient. Okay, and he goes to the computer and he provides his data. Computer analyzes and tells that there is a tumor in his stomach. It needs operation. Okay, it needs operation. So the person asks that okay, what is the probability? What is the probability that there is a tumor? So it says that probability is 0.50001. Probability of being tumor is 0.50001. Or who says 5? 0.3001. With it, or I can say the probability of tumor is 0.0001. This is the probability of tumor. Na? So What? So now what this person would say to this particular computer? Please tell me. Hmm? Am I able to am I able to talk to you?
The
Convey my thought?
diagnosis was wrong.
No, no. Why?
Diagnosis is not.
Why it is wrong? He is telling na
Yes.
there is a tumor because this system is made to give you that what is the probability of your tumor. It gives you that your probability of tumor is this. And if there is a tumor, then you need operation. That person need operation. If there is a tumor, that person need operation. If he investigates, he find out the probability is this. So if this,
Some
then
threshold
this,
should be there.
some threshold should be there. Okay, some threshold should be there. But if there is a tumor, it need to be operated. Let's assume that the system is like this, and system is suggesting you this kind of thing. He would tell that what a rubbish it is. Let's assume the threshold is 0.5. Okay, let's assume the threshold is 0.5, and let's assume this probability is 0.500001. Then would you be agreeing with this suggestion?
Yeah.
Yeah, this
No,
probability
sir.
is
We,
9595. Just compare this. If this is probability 0.9595, then you have to go for the operation. Nah? Just save up the threshold and he's telling that go for the operations. Okay. So if you just blindly focus, if you put everything inside the box, these things are inside the box. What is the probability it set, etc. You go to the system, you provide the data, you get the inferences only. If this I don't provide you, then you would not have any kind of belief on this kind of system. That what I don't know that what it is. There is no explanation. If there is no explanation, how can we develop trust on the system? How can we develop trust on the system? It becomes a big problem for us. Okay. We need causality. Means if it has if you are suggesting me something, what causes you to means this causes this, then this causes this, and that's why you are going to find out the solution. Transferability. This changes in this way. This changes in this way. Informativeness. You whatever things you are computing, they are relevant. Okay. If somebody comes over here and I suggest him that go for the operation, this happens these days. I'm not kidding. Okay, this happens these days because these machines are meant to for that particular thing only. If you go for your medical checkup, definitely everybody, even the child who has actually just born, they can find out 10 thousands of problems in him and tell that start medication immediately. This is very much needed. Okay, we don't have any kind of trust on these kind of system. Informativeness is very important that you are whether you are using the same kind of things or not. Fairness and ethical detection, ethical things again comes later. That it should be ethical that what you are doing. Okay. So if somebody has very less money and you are offering him that go for this kind of you sell your house and everything and go for the operation so that I can earn money, it is not ethical. Okay, so we have to find out that what is ethical, what is not non-ethical into the computer system. So nowadays people are talking these things about also that whenever there is a decision given by the given by the computer, it should be interpretable, explainable, so that we can understand, we can build trust on the system. Very interesting idea. Okay, and transparency actually comes with the three levels that whatever this particular machine is doing, that can also be done on pen and paper. Okay, and when it is going to compute something, there should be some parts of that based on this it is going to find out this, based on this it is going to find out this. Decomposability, that we call the decomposability. Simulatability means we can do it in pen and paper. And algorithmic transparency. Okay, so what he is doing, we should be knowing that okay, this thing is happening this way. There are various models such that actually try to achieve this kind of things. And one you know that most popular is the decision tree. However, it has been seen that in very extreme scenarios, they also fail to provide any kind of insight that why the things are happening. And linear model is again, linear model is very easy to explain. If this is the data, you say that this part is going to be this part is going to be linear model. So they actually define lines and tell that by this portion is have the error, this portion can have something. The linear models actually their objective is this, that they can give better visualization. Decision tree, you know that based on this thing you are going to give in go in this direction or this direction. So everywhere you are clear that why you are going to this particular direction. So decision tree and linear models, they are actually uh, some example of interpretable model or explainable model. If I ask the question that give me examples of interpretable models, so decision tree, linear model. But however, if I ask you that what are the issues with them, then you must tell that if the number of things increases, then decision tree becomes useless. Okay, when number of things becomes increases, here also you can see that multiple lines. If the system is very complex, then linear model is also not able to explain the things. However, at the first level, for the simple problems, decision tree and linear models are effective to explain you that how to do the things. Thank you very much. Thank you very much for your attention. This is all I have today.